Question 15 and 16. Which equation is a propagation step in the conversion of trichloromethane into tetrachloromethane by reaction with chlorine in the presence of ultraviolet light? So if you've got chlorine in the presence of ultraviolet light, you've got free radicals. You've got atoms or groups of atoms with a dot, an unpaired electron on there. So A is definitely not it, because that's not even a free radical reaction, so it's not A. So you're looking for reactions with dots in them, so it could be B, C or D, but it's definitely not A. If you have an initiation step is where the dots only appear on the right, so you've got something like chlorine Cl2 making 2 Cl dots on the right. So we haven't got anything like Cl2 going to 2 Cl dots. We've got no initiation step. Okay, we're after a propagation step anyway. A termination step is where two free radicals come together, two dots, to make something without dots. So that's a termination step, B. Two dots coming together to make something without dots, two radicals coming together and joining together and forming something with covalent bonds without dots, with no unpaired electrons. They're all involved in covalent bonds, shared pairs. So it's not B, so it's not A and it's not B. So we're between C and D. Which one looks possible? So a propagation step, you never find an H on its own, an H with a dot, so I'm never going to find that. I'm never going to produce that. If I had those two coming together, then the Cl dot would react with an H and make HCl and a CCl3 dot. So a Cl dot always makes a HCl, never a H dot. So it's definitely not C, so it's got to be D. It has to be D, and that looks correct. So I've got CCl3 dot reacting with more chlorine to make CCl4. It says it's making trichloromethane into tetrachloromethane. There's tetrachloromethane, and it's making a Cl dot, so it's reforming the radical, the chlorine radical, which is part of the reaction anyway, to reform the Cl dot as a catalyst. Your answer is D. Which compound has the fastest rate with potassium cyanide to form pentane nitrile? So which one of these will react with potassium cyanide? A cyanide ion is a Cn- with a lone pair on it. It attacks the carbon bonds to a carbon, and then either the Br, the Cl, the F or the iodo release then, so the bond breaks. So as the Cn- ion and the lone pair bonds to the C, then you need the Br, Cl, F or I bond to break, the electrons to move from the bond onto the Br, Cl, F or I and make a Br- ion, a Cl- ion, an F- ion or an I- ion. Which one will go the fastest? It's the one with the weakest bond. The one with the weakest bond is the largest atom because the shared pair of electrons are not held as tightly. So the iodobutane has got the weakest, largest iodo. Iodine is the atom at the bottom of group 7, the larger atom, and so that's going to have the weakest bond.